Okay, so we're going to start today just briefly getting into 1.7, which is modeling with functions. Okay, so basically we're going to be creating equations to model different situations, and we're going to take known equations that you guys have from like geometry and some other stuff like that, and try and produce some new ones using substitutions to help us out. So I want to start with an example here, and we're going to engage your memory here a little bit. Area of a circle. What's the formula for the area of a circle? Yeah. Nope. That's the circumference. Yes. Pi r squared is the area. Yeah. So you have seen this formula before. Okay. But actually that is just one equation for the area of a circle. I can make all sorts of equations for the area of a circle. It all depends on what is it a function of. Okay? So this particular area of a circle equation, what is it a function of? R, the radius, right? So technically, if I'm going to use this as my area of a circle equation, that would be A of R equals pi r squared. Area of a circle as a function of its radius is what that is. So let's say I wanted to create another equation for the area of a circle, but I wasn't interested in using the radius. I wanted to use the diameter. Okay, so the diameter of a circle, someone actually already mentioned this one, it's 2 pi r. So if I want the area as a function of diameter, how could I take this information and do that? Knowing that this is the area as a function of the radius, and the diameter, oh, I'm sorry, that's circumference. Oh my good lord. Sorry. You're probably like, wait, what? That's not right. Okay, 2r, right? Yeah, I'm stupid. So d equals 2r. So let's try this again. So area of a circle, pi r squared using r, but diameter is equal to 2 times r, so how could I then create an equation for the area using d instead of r and all that information? Yeah, Josh.
Couldn't you set up like the diameter so that it equals r?
Okay, so we're doing a substitution with the r, so I'm going to have to work with this a little bit first technically before I can do that, right? So I need to solve that for r, which would be r equals d over 2. And so now I can take my known equation, pi r squared, and do a substitution for r, put in a d over 2 instead of r, and then simplify that up as far as I can, and that would be my new equation involving d. So I'd have pi times d over 2 squared. And we can simplify that up just a little bit. If we have a fraction and we're squaring a fraction, how do we do that? Square the top, square the bottom. Okay? So this is pi times d squared over 4. And then just because it's kind of a more accepted way to write it, since pi is technically a number, I could take the pi and the 4, make it a fraction, and then the d squared can come off the 4. So kind of the cleanest looking version of this would be pi over 4 d squared. So now I have an equation for the area of a circle that works, but it's nothing like you've seen before. Okay, now it's if I want to know the area of a circle and I have a diameter to plug in, I can use that equation then. Okay, so let's try this one more time. Now we're going to use the circumference. Okay, so again, we'll come back to where we were at, a of r equals pi r squared, and then we know the circumference of a circle is 2 pi r. So see if you can do the same kind of thing here as we did with the diameter. And now I want my area as a function of the circumference of the circle. Okay, so take a couple minutes. See if you can repeat that process now, but make it a function of c instead of a function of d. All right, anybody need more time with that? All right, I'm going to unfreeze here, show you what I have, and see if it's what you have. Now, I did some simplifying here too. So the substitution is the key step, but we'll work on the simplifying a little bit as well. But I ended up with c squared divided by 4 pi. Okay, so first thing, r is equal to c over 2 pi. Okay, that's what we're going to substitute in this time because we have an equation involving r, so we can substitute that piece in. So we got pi times c over 2 pi squared, because that's our r. Yeah?
How would it become c over 2 pi?
I divided each side of this equation right here by 2 pi, because I had to solve it for r. So you got to divide by the 2 and the pi, so I just did it at the same time. Okay, and then here's my substitution step. Okay, pi r squared, but it's that c over 2 pi. And then I squared that fraction, so c squared. The 2 and the pi both get squared, so it's 4 pi squared. But then I noticed that I had this pi out front that would cancel one of those pi's. So it was c squared over 4 pi. Okay, and that would be your area of a circle equation in terms of the circumference. So as a function of the circumference. Okay. Yeah, I'm going to do another one that's not using circles, but similar to the same kind of thing. Yep. The next one we're going to look at is actually a cone. I think this one's a little simpler, actually. But if you don't remember the volume formula of a cone, we need that for this one, though. So let's say we want to write the equation for the volume of a cone whose, what did I say, height is 3 times its radius. As a function of its radius. All right, so it's going to be a volume of a cone as a function of its radius. But this is a particular cone where the height is 3 times the radius. Okay? So let's start with what we know. Okay? So, what do we know? What can we write down? What relationships do we have in this problem that we're going to need? Yep. The height of the cone is equal to 3 times its radius. H equals 3r. Okay, that's key. What else do you notice in this that we're going to need? Yeah, volume formula for a cone. Anybody remember what that is? All right, 1/3 base times height, correct. And what is the base of a cone? Mm-hmm. So it's that. 1/3 pi r squared h. So, what do you suppose now, if the volume is a function of the radius, what do you suppose I need to do? Yeah, go ahead.
Substitute in 3r for h?
Mm-hmm. Yep, exactly. Because after I do that, v equals 1/3 pi r squared, and then instead of h, I write 3r. Notice now the formula for the volume that used to involve both r and h now only has one variable in the mix, right? Just the r. So if I simplify what I have here, now I've got a volume formula for my cone as a function of r. There's just r in that formula now, okay? So this one, the simplifying is not quite as tricky as some of the other ones we looked at. What do we have to do here to simplify it up? Anybody notice anything in there that's going to cancel or combine together, that sort of thing? Yeah?
The 3 and the 1/3.
Mm-hmm. They will cancel. Yep, the 3 and the 1/3. So V of R. Okay, so those are gone. And then what else is going to happen once I get rid of those? The, right, so it's going to be pi R cubed. That would be it. Okay, what if I wanted the volume as a function of the height instead of the radius? Okay, how would this change? Oh, question. Mm-hmm.
Why did 1/3 cancel?
Because 1/3 times 3 is 1. So that would just, yeah, so it'd be 1 pi R cubed, but yeah, you don't need to write the 1 then at that point. Mm-hmm. So let's try this again, except let's do it as a function of the height, and just see how it changes. So we're still going to start with the same information. H is equal to 3R. V is 1/3 pi R squared H. But if I want to be a function of its height, then the formula that I have when I'm done can't have R's in it. It has to have H's in it, right? So that's going to mean my substitution step is going to change slightly. So how am I going to have to change things up to make that work then? Yeah, Jeff. Right, so this little H equals 3R, I'm going to have to change to R equals H over 3. I'm just doing a quick little algebra solve for R there. Because now, if I substitute that in for R, I'll have eliminated the R's and I only have H's. Okay? So that's going to be our next step here, is to take this volume formula again. And it's going to be 1/3 pi H over 3 squared times H. Okay, same idea, but again, it's what's the result that I want? I want to have H's instead. So here, and again, it's just a matter of simplifying this thing the rest of the way. So V of H, well, let's see. I'm going to have 1/3. When I square this H over 3, what's that going to become? H squared over 9. So what's this fraction going to be in front then? If I got a 1/3 here, and I'm going to have essentially a 1/9 here. 1/27. Yep. The pi is still there. And then I'm going to have an H squared times an H. Right? Because I've already used the 9 from here and brought it out to that fraction. So H squared times H, what's that going to be? H cubed. Okay. So that's acceptable, or I guess maybe a little bit cleaner. V of H equals pi over 27 H to the 3rd. So that would be doing it as a function of its height. Okay. So, the idea with that, okay, you're going to have to draw on some geometry formulas from the past. Anything too terribly complicated, and I will, like on a test or whatever, I will give to you. And I will let you know when we're reviewing for your test which formulas from geometry you should have memorized and which formulas from geometry that I would be giving to you. Okay? So we'll do that as part of our review. So, okay. So that's using those substitutions. I do have one more example that is similar in nature, but requires a little extra work. In this example, we might not have time to completely finish, so we'll kind of see how we do here. But I want to at least set it up, and then we can get back to it tomorrow. So let's say the lengths of the two legs of an isosceles triangle are 4 times the length of the base. write a formula for the area of the triangle as a function of its base. Okay, so I don't want to dig into this one just yet, but I want you guys to start thinking about it a little bit. Okay, area of a triangle involves what two measurements that we will need to know? The base and the height. Okay, the one thing that I haven't made any mention of on here is the height. Okay, so be thinking about how can we take the information that we have right here and get something about the height going. Okay, there's a certain theorem from geometry that we use a lot that's going to help us there. Okay, I don't know what it is, but be thinking about it. Okay, here we go. So yesterday, I presented you with this problem. The lengths of the two legs of an isosceles triangle are 4 times the length of the base. Write a formula for the area of the triangle as a function of its base. Okay. And I said, we got to think about the area formula for a triangle, and then be thinking about what you might need to use to find the things you need to find the area. So let's start writing some of this stuff down. The area formula for a triangle is what? Base times height divided by 2. I prefer the 1/2 base times height, but it's the same thing. You're right. Okay, so we're going to be using that. And then I said, okay, think about what of that we have in the mix here and what we don't. I want this to be a function of its base, right? So that means when we're done, we should have an equation only involving b, not h, correct? So we need to make a substitution for h somehow, okay? So there's going to be some geometry in the figure that's going to be helping us with that. So if we draw our isosceles triangle here, so here's our base. And I said that the other two sides are 4 times as long. So what should I have here and here then? Or 4b, right? 4b. Now, it would be super nice if 4b was the height, because then we could just plug in 4b, right? H equals 4b, substitute it in, figure it out, we're good. But it's not. The height is perpendicular to the base right down the middle of this thing. There's h. So, I can't use 4b directly. However, I can, like we mentioned yesterday, use the Pythagorean theorem to help me come up with something I can use for h. Okay? So, let's consider for a moment just this right triangle right there. It doesn't matter which one you choose, because either one's going to have h as part of the triangle. Okay? But, if I'm going to do a Pythagorean theorem just in here, okay, what am I going to have? What squared plus what squared equals what squared? How would that look for that particular triangle? Yeah.
Half b squared plus h squared equals 4b squared.
Mm-hmm. So half of b squared, that would be from the bottom, right? Plus h squared equals 4b squared. Okay. And what am I going to have to do with this now? This Pythagorean theorem equation that I've pulled out of this thing. Well, ultimately, what's the goal, though? Solve for h, right. And beginning that process, we're going to want to square some things out and move some things around and all of that. So let's start doing that, okay? Got to solve it for h. So 1/2 b squared. You're going to square the half and square the b. So it's a quarter b squared. H squared is still h squared. 4 squared and b squared on the next part here. So that's 16 b squared. Okay, and then you're going to do a subtraction, right? We've got to move the quarter b squared to the other side. And those are like terms, right? They're both b squareds. So we're going to do 16 minus a quarter. Okay, and I don't care if you want to slip into decimals here because it's a little easier. So it'd be 15.75, right? Once you subtract. Subtracting a quarter from 16, so yeah, 15.75 b squared is fine. And then what? Square root it. Now we've talked about if you square root both sides of an equation, technically you need to have the plus or the minus, right? However, in this case we don't. Anybody know why? Yeah.
Because it's a length of a triangle and you can't have a negative length.
Exactly, right. The negative part of that answer doesn't make sense in the context of the problem. We're talking length of sides of a triangle. You can't have anything negative that's a length. So we just take the positive for this one. Okay? So that kind of works out nice for us. But in any event, it's the square root of 15.75 b squared. So I'll pull out my handy-dandy calculator. So the square root... where's the square root in this? Ah, there we go. Square root of 15.75 is about 3.97, somewhere thereabouts. And then the square root of b squared is just b. So that's going to be the substitution I want to use. Okay? So if I go back to my area formula over here then. So the area is 1/2 b multiplied by this 3.97b. And that can be simplified a little bit, right? Multiply the 1/2 with the 3.97. So divide that by 2, get about 1.98. And then we're going to have a b squared. So our a of b is 1.98 b squared. That would be the final formula. Okay, so sometimes we might have to employ the Pythagorean theorem to help us out, especially when you're talking area of triangles like this. Because the area of a triangle is reliant on that height, and so you have to figure out a way to get at that height in terms of whatever the variable is you need. In this case, it's the base b, and then you can do your substitution back in. Okay, but in general, it's the same kind of idea. We just got to go through that first. Okay, okay. The geometry, making formulas kind of thing, and transition here just a little bit. I'm only going to do one example of this next thing because it's pretty straightforward, and you've done a lot of it in the past. And there's going to be some problems in your assignment involving percents, and I just wanted to briefly talk about that. So if you're going to talk about something that increases or decreases by a certain percent, okay? At some amount that's going to increase by X percent. So it could be, 32%, 56%, whatever it is. We're just going to call it X for now. Okay? What do you do to the amount you have right now if you know that it's going to increase by a certain percentage? What do you actually multiply it by? Exactly. It's always 1 plus whatever that percentage is. Okay? So to do that, you're going to take the amount and then multiply it by 1 plus the X percent. If you're going to decrease by a certain percentage, how does that process change then? It becomes just a minus, right? Yeah. Yep. So it's whatever your current amount is multiplied by 1 minus X%. So we're going to use this idea to just work through story problems, that sort of thing. And like I said, I'm just going to do one with you. You'll have a couple on your assignment to take a look at. So let's say we've got a population has grown by 35% over the past 5 years and is now 2 million people. So what was the population 5 years ago? Okay, so is this an increase or decrease problem? It's an increase, okay? Now, does that mean you take 2 million and multiply it by 1 plus 35%? No. Take a look at how I set it up. It says it has grown by 35% and is now 2 million people, right? So this little equation up here that we talked about is going to be equal to 2 million. That's the final result of the growth, right? So we're going to have some amount times, and take the percent and turn it into a decimal as well. So 1.35, so something times 1.35 has gotten us to 2 million. Okay, and instead of, if you don't want to use the little AMT for amount, I mean, you could turn that into just X or whatever. I think I'm going to just make P instead of AMT. So population times 1.35 got us to 2 million. Okay, so once you got it set up, then it's pretty simple, right? Just solve that equation. Divide, done. Okay, so what was that old population then before the growth? $436,000. That seems awful small. That sounds better. Say that one again. 1 million what? Anybody else get that one? Yeah, okay. That sounds a little more reasonable. Maybe you missed a... You probably did 200,000 instead of 2 million. That would be my guess. So 2 million divided by 1.35. Yeah, it's the 1481481. Yep. Nope. Because of the fact that I said over the past 5 years it's grown this much. So what was it 5 years ago? It's the same time interval, so it doesn't matter. I know over that 5 years it's been that 35%, so it's not going to change. Now, if I had asked what was the population 1 year ago, that would get a little bit more sticky, but we're not. Exactly, that it's growing by the same amount each year, turning it into an exponential problem, and then solve that. But we're not doing that with this stuff. It's just a straightforward percentage of growth. So, yeah, don't want to make it more difficult than I need to. So, that would be it. Okay, so just wanted to make sure we're still okay with how percents work that way. We have to add it to 1 or subtract it from 1 and use that to help solve the problem. Okay, I'm going to stop, let you guys get going on some work here.